Hello guys and girls, today I'm going to show you how I've implemented a decorator inside POL eScript. So how I did it, I've created a decorator variable as an array, and this array will receive the functions in the order that it's said. Function B will be decorated by function A and will be decorated by the next one and so on, right? So how I do this? Each function, let's see right here, each function must receive the decorator itself because it needs to call the next function in the chain in the decorator, and it needs to know its current index, and it also needs the parameters. I'm using by ref because it's easier than returning the values and reassigning variables. So I use the first first created variables all the way through, right? So in here I have two parameters and all functions must match the same call. So I have both functions calling the same parameters. Okay, these first two are how I do this, and the rest is parameters in general. Okay, so to call this decorator, I'll use this call. In the decorator, I call the last added one, which has no one decorating it. So function A in this case has no other function decorating it. Um, and I call it passing the decorator itself. Remember, it's by ref. The current position, which is just the same one that I've called, and the parameters that are going through the decorator. So in the first test, the first one being called is function B. So let's see how it does, or what it does, how it works. So what I'm passing here, let's check here, right? I'm passing an empty string as parameter 1, and parameter B is a 0. So the first function to be called, which is the last one in the decorator, is number 2, is the position 2. So the index here in function A is 2. And it receives the parameter as it should. What does it do? So it checks, it's the only thing it does before calling the next one, is that it checks if parameter 2 has a value different than 0. And it doesn't because it is 0. We just seen it. And parameter 1 would be changed to 1, 2, 3, 4 if that happened, but it didn't. So it goes to the next statement. The next statement is an if that checks. Rather, there is another function to be called. Am I decorating someone? Yes, I am, because I'm greater than 1. If I were 1, which will happen in the next call, I couldn't have an index -1 because it would be index 0. And in here we don't have index 0. The last one would be 1. So am I decorating someone? Yes. So call it, passing the same parameters and their position in the array, which was index my position -1, right? So what it does is entering the next function, which is function B, with the same parameters because I did not change them, right? What function B does? Function B first changes the parameter 2 to value 1. So now we have a value of 1 in parameter 2, right? And do this function decorate someone? In this case, no. So this will not be called. We go to the next check. The next check verifies if parameter 1 can find the number 23 inside it, but our parameter 1 is empty when it enters this function. So it's not going to find 23. Therefore, it's going to fill parameter 1 with no, no, no. Instead of ha ha ha, it will change it to no, no, no. And we will send it back out of the function that is in position 1, which is function B. Function A will receive these parameters, but it will do nothing. Just go back all the way through the chain. to the decorator. So we have just the changes that happen in function b, which is parameter 2 is going to be 1, and parameter 1 is going to be no, no, no. But in the next test, I do the other way around. I do function a being decorated by function b. What happens? Using the same input parameters, parameter 1 being empty and parameter 2 being 0, I have uh, the function b being called first, and it enters as position 2, index 2, in the array. So it receives the parameters, and what it does in here, it just changes the parameter 2 into 1, because now it has someone to be called to be decorating. I am function b decorating function a, so I'm going to call function a in here. This is going to call function a. And my parameters are already changed because function a will now receive parameter 2 as 1, which means when it enters this check, it will pass this if check, this if statement. So parameter 1 will be changed into 1, 2, 3, 4. And function a now decorates no one, so it ends the function because it has nothing else to do. What returns from function a that's in the index 1 is the changed parameter 1 into 1, 2, 3, 4, and the changed parameter 2 into 1. The changed already happened in function b, so it's still changed, right? Now function b, after calling function a, has some different value in parameter 1, and it contains 23 or 23 because parameter 1 now is 1, 2, 3, 4, and inside it we have 2, 3. So it's not going to change it to no, no, no. It's going to change parameter 1 into ha, ha, ha. And that's what we see here. Nothing else is done in function b, so it exits with a different state. I believe now you understand how I've implemented it, and maybe understand, if you didn't before, how a decorator works. But how would I use a decorator? Why would I use a decorator? So you could have something like this. Think like function disconnect could disconnect a character. So a character connected would be 0 if something happened, if some check is done. It could decorate a function that, like, kill whatever, that will only kill the character if the character is connected. If the character is connected, character kill. You could think of it like that. So this check would not only disconnect the character, but it will also not kill it. Another way of thinking it, you could have a function, colorize, and in this function, you have a call of another function create. And the function create will have an item creation, create an item. But if this item exists, it could colorize. Otherwise, it wouldn't, because there's nothing to colorize. So you can have a function that always colorize, but it only colorizes if it creates. This is a simple example of how a decorator could be could be created. Why would you use a decorator? But it's a good way of thinking because colorize function will always colorize, no matter what happens. But it must have an item. So if I have an item, I will colorize. If I don't, I will not. And that's it. That's a simple way of thinking, but it could be implemented in many different ways to do many different things and create a generic way of programming, but still doing everything you want. So enjoy.